Hello everyone, this tutorial you will able to learn about MIPS branch instruction, and it helps to solve you the classwork for the second class. So as I discussed in the class, in high level language like C or Python, we need to use if-else statement or case statement that break the sequential flow of the code. So depend on the condition, it jump from one location to another location, and the program counter is also updated accordingly. So we have two types of branching. One is the conditional branching, and another is the unconditional branching. Well, let's move to the conditional branch. So within the conditional branch, that means it will be branched, or it will change from the current position to jump in another position based on some condition. So if the condition is true or if the condition is false, then it's interrupt and jump. Well, so as I said, that based on the condition, so the condition could be true or false, right? So based on these, the conditional instruction further categorized into two types. The first one is branch if equal, or BEQ, and the second one is branch if not equal, is BNE. Here is example of branch if equal, the register 1, the register 2, and the immediate. It says if the value of this register and this register are same, okay, it jump to the level immediate, IMM. Similarly, BNE, or branch if not equal, here's example. So these two registered value is not same. If the value of these two register RS and RT is not same, it jump to the level immediate. What we understand so far, so we have two types of branch, the conditional and the unconditional. And within the conditional branch, we have two types of instruction, BEQ and BNE. That means branch if equal or branch if not equal. And this is the example. Let's have an example. So this is the instruction that you already know, add immediate. So it says that add immediate 4 and the register 0, that means 0. So add 4 with 0 and store it to the S0 like this. S0 is equal 0 plus 4. Now it's 4. Well, the next condition is the value of S1 is S0 add I, so 0 plus 1. So S1 is 0 plus 1 is 1. After that, shift left logical, that means the value of S1 is shifted left by 2 bit. That means is the value, if the value of S1 is shifted 2 bit, that means is multiplied by 4. The current value is 1. If you shift 2 bit, then 1 is multiplied by 4, the result is 4. So right now the current value of S1 is 4, also the current value of S0 is 4. Here you go, the statement branch if equal and the register are S0 and S1. At this point both S0 and S1 are same, so it jumped to the target, the level target, and it without executing this line, it jump over here and then start executing S1. So it says the S1 is S1 plus S0. So it update S1 4 plus 4. So S1 is 4 and S0 is 4. So it added and also put it in the S1. So what we learned from this, what we observe from this example, if the branch if equal executes, that means its condition is true, without executing the next line, it jump to the level. So what now we, with this example we understand that if we have conditional branch, that means this is true, same, so it jump. Okay, now come to the point, how you write the assembly code or machine code for this. Okay, you know the opcode, but how about the remaining part? So the opcode is, you know the opcode here. So this is the example. So you write down the BEQ T0 0 and then the label is else. Okay, so if the value of register T0 and S0 is same, it jump to the label else, I mean here. So let's count the, this is, now we are here A4, and after 1 2 3, so the label is in after 3 line. So you know the value of T0 and the value of 0 register from the register table. So it is 8 and 0, and the immediate value is 1 2 3. So you need to put down 3 here. So once it put 3, so it means that the next level, we found the next level in the after 3 line. So the machine language is just converting this decimal value to the binary. Well, we understand that if you line the number 3, 1 2 3, but how the address of the 3 is before calculated. So now you are in A4 and you have the immediate value 3. So with this value A4 and 3, you need to find out, you need to calculate the value of the level, that means B4. And here is the example. So before going to instruction, this is a note that while you write the instruction level, you have to write down the instruction name. Okay, so during so when you write down, when you write the level, please careful that you cannot, you can write any string as a label without the instruction name. Okay, well, now in this example we will calculate the value B4 is the address next to execute after executing A4. So right now the program counter hold the value of A4 while this branch if equal are executing. Well, so let's move to the left side is a calculation. So the program counter right now is in A4 and you have the value 3 and we need to calculate the next address as B4. Well, so here is the result. So we need to do the calculation in between. Well, as you know, the first thing is you need to add 4 with the current program counter. Okay, this is the rule. You need to add current 4. And as you know, the MIPS address, the last 4 16-bit immediate here in the add. So you have 16-bit immediate 3, isn't it? Then the remaining part are the sign extend. So if it is positive, you have to put all the way 0. So in that case, it is 3, so you need to put all 0 here. Okay. So we got these and these, and always the last 2 bit of any MIPS address is 0. Well, so now we need to calculate, we need to conclude with the B4. So what we have to do, we need to shift this 3 by 2 bit. Okay, that means you need to multiply 4 with the immediate value. So here the immediate value is 3, and once you multiply 3 with 4, you got the 12. So what we have, you have add the 4 and then add the 12 with the A4, and then you will get the B4. So here is the example. So right now the value of the immediate after shift is 12. The value of the immediate is 3. After shift 2 bit, it become 12, and you need to add 4, and then it's 16. So 16 in decimal is equal 10 in hex. Okay, so what you have to do, you need to add 10 in a hex calculator with the A4. So A4 plus 10 is B4. So the next address is B4. So this is the third thing that you need to remember. Well, now move to the unconditional branch. So as you know, the early example, we check whether the condition, that means the 2 register, is value is equal or not based on this jump. But now we will check the regardless of the condition, it directly jump to the level. So we don't have any and the format is J and the address. Well, so here, so once the program come here, so it directly jump to the target. So now look at the example here. So it also need to solve your classwork. So in the line 20, there is say the J and then 2. That means you need to go to the number 8. So same to the branch equal or branch if not equal. Now we calculate how we can gonna find from 20 to 8 with the value of 2. Well, the current program counter is in 20 right now. Current program counter is 20. So we have to calculate the next program counter that's supposed to be 8 after executing this instruction J2. Let's go to 8. Well, as you know, the first 2 bit and the last 2 bit here comes from the same as the program counter. It's the same as the program counter, and the last 2 bit is always 0. Now the remaining bit comes from the immediate value 2. So we have the immediate value 2, and you need to shift it to bit. That means multiplied by 4, so you will got the 8. That's it. So in jump instruction, in J, you don't need to add 4. You need to just shift and calculate the next address of the program counter, and it would be the 8. So this is the way you calculate the value. And in your classwork, you have to do the same thing for conditional statement, conditional branch. Okay. Yeah. So you got the address from here.